All right, so today I want to talk a little bit about one of my favorite pieces of magic in the Elixir language itself, which is the magical pipe operator. So a lot of times in writing software, you end up with bits of code that sort of look like this function here I've called order total, where you end up creating lots of temporary variables, each of which gets used on the line below it and really nowhere else. So you can see I've created this mythical function called order total. It takes lines. Each line represents a price and a quantity. So the first thing you do is you run a map across those lines to take the lines that show the price and the quantity and have it simply return the line item for the price, which is price times quantity. So, and then you take that order of line items and then you sum them using enumSum in this case. Then you create or you calculate the tax amount by taking the subtotal, multiplying it times the tax rate. And then tax rate came from somewhere, of course, don't worry about that right now. And then you take the subtotal of the tax amount and that's what you return, and that's the total price for the order. And so there's lots of reasons that people write the software that way, and one of them being that some of the alternatives are actually a little bit worse. So just to sort of move this into a domain that's a little simpler and doesn't require me to go and define a bunch of those structs, I've created a slightly contrived example here of some things you might want to do with a list. So in this case, we create a list from the numbers of 1 to 5 inclusive, and then we take those numbers and we square them all, multiply each one by itself, and that results in list 2. And then we take list 2 and we filter it looking only for the even numbers. That is, numbers where when you take the element of the list and divide by 2, the remainder is 0, and then that's the resulting list from TempVars. So we could do this using nesting, and certainly lots of functional programming languages take this approach. So to create this from a nested perspective, we kind of start at the bottom and go up. So the last call is in enum filter, so that's the one that's got to be in the far left. And here where we have list 2, we need to replace that with however we created list 2, which was by calling enum.map. And the first variable to enum.map is list, so we look at how we got the list, and then we call enum.toList. We pass it 1.5. We close that paren. So now we're back in the map function, so we have to define that function. Say x is x times x, end, close paren. And now we're done with sort of the creation of list 2, and now we can go back into the filter and complete the parameters for that. And that will be pass in x and return once whether the remainder is 0. Go ahead and keep that on. Okay, that's kind of ugly. So we'll do that. So here you can see this should be functionally equivalent. And you have to sort of read it from the inside out. Enum.toList 1 through 5, and then enum map that list using that function, and then enum.filter using this function, and it should get you the final result. Now, the magical pipe operator, if you've ever spent much time programming on a Unix command line, you know the Unix philosophy of small programs doing small jobs, and then you simply use the pipe character, which in Unix is simply that character to take the output of one command and run it into the other. I always end up using this as I'm sort of analyzing directories using sort and cut and unique to analyze the data. So Elixir gives us an option that I think is better than nesting, and it's better than the temporary variables, and that is the magical pipe operator. It's the regular pipe followed by the greater than symbol. And basically what this does, it takes the output of the command on its left and passes it in as the first parameter to the function on its right. And you can, of course, chain these things together as much as you want. So in the case of what we're doing here with TempVars, we'd simply say 1.5, and then we call enum.toList, and that's it. We don't have to, since the 1.5 is the first parameter and the only parameter, we're done with that. And then we simply call enum.map. and we skip the first parameter of the list, and we simply define the function, and we're done with that. And the last one is the enum.filter, and we skip the list because the pipe character took care of that for us, the pipe operator took care of that for us, and we simply define the filter method for us. And that's it. So down here you can see we're calling the temp var version, the nested version, and the magic version, just to make sure we're getting the same answer every time. Of course. Yeah, okay, right. We'll go ahead and kill that. Okay. Temp vars, so picky. Okay, so we're getting the same answer from each, but you can see that, so in the pipe version, we've got the benefit of the temp variables and that each function calls on its own line. So if something bombs out, we'll find exactly the line that went wrong, as opposed to the nested version where it looks like they're all on the same line of code as far as the interpreter is concerned. But we also don't have the temporary variables laying around, and you can simply pass things from one to another. And this is really handy, just even doing what I just showed you. But one of the real advantages, okay, is in stream processing. So as I mentioned before, streams are lazy, which means whereas an enum wants the whole list before it gets going, a stream is happy to basically, you can set up a chain of commands with stream, and then when you first start to process the input, that's when things will start moving through these functions. So here, this is from a little program I was working on. I think we'll get into some of the details of this in the future. But you can see I'm reading a file line by line. So when you call file.stream, that turns it into a line by line read. The very first thing I'm doing is taking each input line and mapping it to the output of a regular expression check. So I'm looking for a particular line or a format of a line in the files. And so the output of that comes into the filter. So when the regex it fails, it returns nil. When it works, it returns a list. So here I want to get rid of all the lines where the regex failed, and where it succeeded, I simply want to keep it. So we use the filter. And in this case, in the map, it returns in a list the first variable I do not care about. The second variable is the text that I want, which is actually the text of a tweet from a Twitter data download, and simply return the text of the tweet. And then I return all of that into a list, because that's what my other function wants, where I parse the tweets and pass the list into parse tweet. So by chaining these together using the pipe operator, I'm actually able to sort of stack these function calls before I ever read a line from the file. And this is actually this call from enum2list that tells the interpreter, okay, now it's time to go through the file line by line, run it through the map, the filter, the map, and give those results into toList, which in my case, generally I've returned about 1 out of every 40 lines or so into this list, and the rest just gets filtered away and ignored. Doesn't sit in memory, doesn't have to sit in temporary variables ever, and then that list goes into parse tweet. So the pipe operator is super handy. It's a great way to chain things together, but into readable code, and into code that's actually easy to debug when the interpreter doesn't like something you've done. So I think it's a great addition to the tool. I think it makes the code a lot more readable, and I think it's frankly one of the things that makes programming with Elixir a lot of fun. So hopefully that was helpful.